part 3 of the lecture. This is the deterministic effects. Well, actually, let's first have a look at some strange effects that radiation can do that are slightly unexplained. So the first is bystander, second is genomic instability, and the second is hormesis, the third. So the bystander effect. So this is a strange thing that occurs when, if you have some irradiated cells which are in close proximity to unirradiated cells, sometimes they will send signals to the neighbouring cells which will then behave as if they've been irradiated. And it'll be vice versa as well. So sometimes some unirradiated cells will send signals to irradiated cells and they'll act as if they haven't been irradiated. So there's been a number of experiments demonstrating that radiation doesn't actually have to deposit cell energy into the actual cell that you're interested in. So if you take a dish full of cells and irradiate half of the dish, leaving the other half of the cells unirradiated, some of the irradiated cells, or some of the unirradiated cells, will behave as if they've received a dose, and it'll be vice versa. They don't know the cause of this, and there's hundreds of people working on this. They have been for years and years. So there's some sort of communication between the cells. This was very useful in the 1950s to 1970s, before they had megavoltage skin-sparing radiotherapy. Previously, the skin used to get damaged by radiotherapy because there was a lower beam energies. And so what they used to do is irradiate through a grid, and so you'll get a grid pattern on the skin, and then the irradiated cells on the skin would heal themselves. So it does have some use. Another strange behaviour is genomic instability. So there's been some studies saying that sometimes radiation damage doesn't show itself until generations after the actual event. So it's a delayed mechanism, and so even though the original cell is not damaged itself or appears to have repaired itself, sometimes this damage will reappear in later generations, and the mechanism for that is not real clear. There's also some other unexpected behaviour that can occur. One is that you can get an adaptive response or radiation hormesis, which means that sometimes things actually have a favourable biologic response to low doses of radiation. So, for example, some animals that receive a low dose of radiation actually live longer. It's believed that this might be caused by maybe cells, when they repair themselves, they stimulate a hormonal and immune response to other toxic agents as well. So that was just a little bit of a detour there. So let's get into deterministic effects. So first of all, let's have a look at some terminologies which may be useful. One is an early effect. So this is a radiation response that occurs within minutes or days after the radiation exposure, compared to a late effect which is observed like months later. An acute radiation syndrome is caused by a high dose of radiation in a very short period of time, resulting in cell death or organ damage. So this would be the victims of Chernobyl or Hiroshima or Nagasaki. And then there's chronic radiation syndrome, which is longer term. So chronic is longer term, acute is shorter term. Somatic effect is limited to and manifested within the lifespan of the exposed person by affecting somatic or non-reproductive cells, so the skin, liver, lungs, pretty much any organ. Examples can be radiocarcinogenesis, so induction of cancer by the ionizing radiation, cataracts, life shortening, that sort of stuff. Genetic effects affect reproductive cells, so egg or sperm cells, and the radiation damage can appear in the offspring of the exposed person. Let's get these. Whoops, I'll go back up. Some more stochastic effects. So we'll be covering stochastic effects next week. But stochastic effect is a random effect, or so it's a probability effect. So the higher a radiation dose, the more likely that you'll get a stochastic effect. So this could be like cancer. But the actual severity of the effect itself doesn't count on the dose. It's just the probability of getting it. So, for example, the more sun exposure increases the probability of getting skin cancer. A deterministic effect is also termed as a tissue reaction, and it's a biological response, and the severity varies with radiation dose. So this one, yeah, it does vary with radiation dose. So more sun exposure, so UV radiation results in more severe sunburn. All right. Yeah. So let's have a look at deterministic effects. They occur due to cell death. So if you have enough cells in an organ that are killed or affected, or prevented from reproducing or functioning normally, there will be a complete or partial loss of the organ function. So the loss of function could be temporary or permanent, and when the organ is vital and damaged sufficiently, the end result could be death. There may be a threshold, 0.2 grey or higher, depends on the person and it depends on the tissue, and everything in this deterministic effects depends on the tissue type. So the initial individual cellular damage is random, but when you start to involve a large number of cells, the effect of the radiation, if you kill off enough cells in an organ, the effect of it becomes predictable or deterministic. So the damage can be prevented by keeping the doses of radiation exposure below certain levels. So the severity and certainty of the effect increases with dose, and they're tissue and cell specific. Factors which determine the threshold dose. So the threshold dose is the dose below which the effect won't be seen or detected. So the factors that affect this are the tissue type, the state of health of the person, the dose rate and delivery mode of the radiation as well. So here we have just a sample of a graph of deterministic effect. So what we have is radiation dose down here on the x-axis. So as we start irradiating the tissue, we initially won't see any response, but when we come to some point, the threshold dose, what we'll start to see is the organ starts to lose function because more and more cells are being killed. And then this will increase as we increase dose, it'll increase and then it'll come to some point where we get 100% cell death, 100% of the cells killed. Now this is tissue dependent, so we have, for example, here tissue 1 and tissue 2. Tissue 1 is more sensitive than tissue 2 in this case, so you can give tissue 2 a little bit more radiation. In this context, radiation protection aims to keep the doses below the threshold dose as much as possible. The different types of tissues, so for example radiotherapy, this can be used in radiotherapy. So some tissues are more sensitive than others. So radiotherapy attempts to deliver a dose that falls between the dose response curves. So cancer cells tend to be more responsive to radiation because they're rapidly dividing, and healthy cells tend to be less responsive. So if you can irradiate a tumour and put a dose right in this section here, get the dose right, you can kill off the cancer, but try to limit the damage to the surrounding healthy tissue. Alright, so let's have a little look. What are the deterministic effects of ionising radiation? So it depends on whether you irradiate the whole body or just a local tissue, or just like one section of the body. So the whole body radiation, if you do that, you can get acute radiation syndromes like radiation sickness, central nervous system syndromes, gastrointestinal effect, or leading to death. Local tissue irradiation leads to local effects such as cataracts, life shortening, sterility, epilation, that sort of stuff. Secondary deterministic effects might occur, so this could be damage to supporting blood vessels, and which leads to tissue damage. Let's have a little look at some deterministic effects at just doses in less than 2 days. So if you irradiate the whole body and give it 1 gray in less than 2 days, one deterministic effect of that could be death, and that's due to loss of the bone marrow, and then the time of occurrence for that could be 1 to 2 months afterwards. It depends on the person and various factors, but these are sort of general figures. If you irradiate just the lungs, you need 6 gray in 2 days. That will lead to death in 2 to 12 months. Skin, 3 gray will lead to erythema, so that's skin reddening, like sunburn, and that will occur after a few weeks. And then we have all these different effects here. But what you can see is that when you irradiate just locally rather than the whole body, there can actually be higher doses are tolerated.